For decades, we have been told, protein means meat, no exceptions, no debate. That narrative shaped what filled our plates, what dominated our farms, and even our school books. But before industry took over, civilization survived and thrived on plants with more protein than steak, and with an independence that threatened corporate control. Why did these supercrops vanish, and who buried them? The answer exposes more than just missing nutrients. By the middle of the 20th century, protein was no longer just a nutrient, it was a brand. Advertising agencies and industry boards funneled millions into a campaign that rewired public understanding of strength and health. Slogans such as "meat gives strength" echoed across radio waves and television screens, saturating homes with a simple message: real power comes from animal flesh. Print ads paired images of athletes and soldiers with hearty cuts of beef, while school posters and lunchroom handouts nudged children toward the same conclusion. The American Medical Association's annual conferences, once a stage for scientific debate, began featuring sponsored luncheons and branded research sessions. Behind the podium, doctors addressed packed rooms as industry-funded pamphlets circulated through the crowd, blurring the line between impartial advice and paid endorsement. The reach of these campaigns was enormous. In the 1950s alone, meat industry groups spent unprecedented sums, some estimates topping $50 million a year on broadcast and print promotion. Primetime television slots, magazine centerfolds, and billboards along every major highway reinforced a single idea: protein means meat, and meat means progress. The National Livestock and Meat Board, working with advertising giants, orchestrated coast-to-coast blitzes that left little room for dissent. Even medical journals and nutrition textbooks began to reflect this new orthodoxy, often citing industry-funded studies that compared a serving of beef or chicken to the supposed inadequacy of plant-based meals. This was not accidental. Conference budgets and sponsorship memos reveal a deliberate effort to buy credibility. When the American Medical Association hosted its 1956 national meeting in Chicago, industry sponsors underwrote banquets and distributed glossy reports touting animal protein as complete, a term that would soon become gospel in classrooms and kitchens. The message trickled down to local health boards and school districts, shaping curricula and dietary guidelines. By the end of the decade, even pediatricians' offices displayed posters linking meat consumption to healthy development and academic success. The effect was cultural saturation. Protein was now inseparable from livestock, and any alternative, no matter how nutritious or resilient, was written off as inferior. The myth was not an accident nor a misunderstanding. It was engineered, funded, and amplified until it felt like common sense. The question of what counts as protein and who decides had been answered not by science or tradition, but by the highest bidder. In this new reality, the crops that once sustained civilizations faded quietly from view, their stories erased by the steady drumbeat of paid persuasion. Federal budgets do not simply follow the latest science. They follow profit, power, and the demands of industry. In the decades after World War II, government research money flowed into a narrow band of crops, corn, soybeans, and wheat. These grains were not chosen because they nourished people directly, but because they could be shoveled into feedlots and turned into livestock. By the 1960s, more than half of all agricultural research funding targeted these feed grains, leaving protein-rich pulses and drought-adapted seeds with a fraction of the resources. Extension pamphlets and farm bulletins praised high-yield hybrids, while trials for tepary beans or cowpeas faded into the margins. The ledger books of the era tell a clear story. Research on corn and soy expanded year after year, with new varieties bred for uniformity and machine harvest. In contrast, protein crops that matured at their own pace, like amaranth, tepary, or lupin, were written off as too unpredictable for field trials or commercial investment. The result was not a failure of these plants to perform, but a failure to fit the machinery of scale. The 1970 Plant Variety Protection Act added a new layer of exclusion. The law granted plant breeders exclusive rights to new varieties that were novel, distinct, uniform, and stable. On paper, this protection applied to all crops. In practice, it rewarded hybrids, plants that had to be purchased anew each season, over open-pollinated seeds that farmers could save and replant. The act did not outlaw heirlooms, but it made them invisible in the new system. Certificates for corn and soy multiplied, while less than 5% of protections went to pulses or protein-rich grains. Textbooks and school nutrition guides followed the money. USDA's Basic 4 Food Group chart, adopted in the 1960s, placed meat and milk at the center of daily nutrition, echoing the priorities of a commodity-driven farm economy. Curriculum panels did not need to issue a mandate. The funding streams and promotional budgets made the message clear. By the time the food pyramid arrived in the 1990s, the damage was done. Meat had become the default source of protein in the American mind, and the protein crops that once sustained entire civilizations were almost forgotten. The erasure was structural, not accidental. Every subsidy, every research grant, every revision to a school lunch chart quietly reinforced the same story. Protein is meat, and meat is progress. The crops that did not serve this narrative, no matter their resilience or nutritional power, found themselves locked out by design. Angela Garcia stands in the early light, her hands moving through a shallow furrow in the Sonoran Desert. She presses seeds into the sand, small pale tepary beans, each one a memory passed down from her grandmother. The land here remembers drought. Rain comes in brief, violent bursts, and then months of heat follow. Most crops wither, tepary. Beans do not. They wait out the dry spells, roots reaching deep, leaves curling tight to save water. When the rain finally falls, even if it is just once, the plants surge to life. Within 60 days, pods hang heavy, filled with seeds that hold up to 25% protein by weight, matching the best cuts of beef without a drop of irrigation. For centuries, the Tohono O'odham and Pueblo peoples counted on tepary beans to survive in this harsh place. Floodwater farming, a tradition older than any border, turned desert washes into lifelines. After each rare storm, families would gather, planting tepary in the moist earth left behind. The beans grew where others failed, feeding children through years when cattle starved and corn shriveled. Elders remember how extension agents came in the 1940s, urging families to switch to pinto beans or let cattle graze the old fields. But some seed keepers, like Angela's family, refused to let go. Their quiet resistance kept tepary alive, even as government pamphlets and ranch fences pressed in from all sides. Across the Atlantic, in the Sahel, another story unfolds. In the dry corridors of Niger and Burkina Faso, cowpeas anchor the diet. Known in English as black-eyed peas, these seeds are more than food, they are survival. Cowpeas thrive on less than 300 millimeters of rainfall a year, where even millet struggles. In a typical Sahelian village, women and children gather the pods at dawn, singing as they work. The protein content can reach 31%, higher than most grains and rivaling the best poultry. Cowpeas grow beside millet and sorghum, fixing nitrogen, feeding both people and soil. Oral histories trace their journey back 5,000 years, from West Africa to the Americas, carried in the braids and pockets of enslaved ancestors. In the heat of the dry season, when livestock herds shrink and imported rice runs out, cowpeas endure. Farmer collectives in Burkina Faso still save their own seed, trading stories and techniques at weekly markets. They remember the hunger years, when colonial authorities pushed maize and hybrid cereals, promising higher yields that never arrived. Today, new drought-tolerant cowpea varieties, bred by local cooperatives, not corporations, yield up to 1.5 tons per hectare with little more than rain and memory. Cowpea stews, thick with greens and ground nuts, feed families through the lean months. In these fields, protein is not a luxury. It is a birthright, grown by hand and guarded by tradition. From the Sonoran Desert to the Sahel, these crops prove that protein does not belong to animals alone. Tepary beans and cowpeas, shaped by centuries of adaptation and care, hold more than nutrition. They carry the knowledge of how to endure and the quiet defiance to keep growing when the world tries to forget. In the heart of ancient Tenochtitlan, a grain once rivaled gold. Amaranth, known as huahuitle, was more than a staple. It was sacred. Aztec priests shaped its flower with honey and in ritual with blood, forming effigies for ceremonies that bound food to faith. Its seeds, just 2 millimeters across, delivered up to 18% protein by weight, higher than wheat, and with a spectrum of amino acids rare in any single plant. Amaranth fueled armies, fed children, and anchored a civilization that spanned the Valley of Mexico. But power recognized a threat. In 1530, Spanish colonizers led by Bishop Zumarraga banned its cultivation. The penalty for growing amaranth was severe: flogging, forced labor, or even death. Colonial records from the Archivo General de la Nación list more than 20 cases of punishment for those who defied the decree. Wheat fields replaced amaranth plots, and within a generation, the grain that had carried empires was driven underground. Yet amaranth never vanished. In the highlands of Peru and the Andes, its close relatives survived, ground into flour and popped over open fires. Modern nutritionists now confirm what ancient farmers already knew. Amaranth's protein is not just abundant but complete. It supplies lysine, an amino acid missing from most cereals, and packs calcium, iron, and squalene, nutrients needed for strength and resilience. Today, rural families in Oaxaca still toast and grind the seeds for atole, a thick, sustaining drink. In trials across dryland Peru, amaranth yields up to 2.5 tons per hectare, thriving in poor soils where wheat and corn falter. Thousands of miles away, another protein powerhouse took root along the Mediterranean and much later in the sands of Western Australia. Lupins, once dismissed as bitter and inedible, held a secret. After harvest, villagers would soak the seeds for days, draining away alkaloids that made them toxic. This simple process unlocked a food with up to 40% protein, more than any cut of beef or chicken. Romans served lupins as snacks at banquets. In Egypt and Italy, street vendors still sell them brined and tender, a tradition stretching back 5 millennia. The story of lupins did not end in the Old World. In the 1960s, Australian scientists bred new varieties called sweet lupins, almost free of bitterness and safe to eat without elaborate soaking. These lines, developed at the University of Western Australia, now yield up to 4 tons per hectare and rival soybeans in nutritional value. Lupins fix nitrogen, restoring soil for future crops, and require no irrigation in regions where rainfall barely touches the ground. Despite their promise, lupins remained sidelined. Their unpredictable ripening and resistance to industrial uniformity kept them out of the world's dominant food chains. Together, amaranth and lupins stand as proof that plants can match and even surpass meat in protein. Their histories are stories of survival and suppression, of knowledge nearly erased but never fully lost. Each seed, whether ground for ritual or soaked for supper, carries the memory of a time when strength came not from animals but from the quiet resilience of the harvest itself. A lab report lands on the desk with a quiet thud. The results are clear. Animal protein delivers strength, but not without a cost. In the United States, nearly 70% of all antibiotics are used on livestock, not people. This routine dosing breeds resistance, contaminates water, and leaves traces in the food supply. Alongside protein, Meat brings saturated fat, cholesterol, and a metabolic burden that lingers in the bloodstream. Epidemiological studies link regular meat consumption to higher rates of heart disease, inflammation, and diabetes. In the same trials, diets built on protein-rich pulses such as beans, cowpeas, and lupins show lower cholesterol, steadier blood sugar, and improved gut health. The difference is not just in the protein, but in the company it keeps. These crops provide fiber, minerals, and plant compounds that buffer against disease. Skeptics point to anti-nutrients such as phytates, lectins, and alkaloids as barriers. But the lab evidence tells another story. Simple processing methods, soaking, boiling, and fermenting, reduce these compounds by up to 80%. Lupins, once bitter and toxic, become safe and tender after a week in brine. Boiled amaranth loses most of its oxalates, unlocking calcium and iron. Pressure-cooked beans shed lectins and oligosaccharides, easing digestion. The result is protein that is not only as abundant as meat, but safer, more complete, and paired with nutrients that support the body instead of taxing it. This is not a story of deficiency. It is a story of abundance, obscured by convenience and profit. The evidence stacks up in quiet columns, blood panels, metabolic assays, long-term health records, each one pointing to the same conclusion. Protein. Adequacy is not a matter of animal versus plant, but of how and why we process what we grow. In the summer of 2011, when the Texas drought scorched pastures and dried up reservoirs, most farmers watched their cattle herds shrink by a third. Ranch auctions stretched late into the night, the air thick with dust and resignation. But in a corner of Starr County, a different story unfolded in the pages of a farmer's notebook. Tepary beans, sown in sandy rows, pushed through the heat. No irrigation lines, no fertilizer trucks, just a handful of rain and a memory of how to wait. By harvest, the tepary plots yielded nearly a ton per hectare. Protein-rich seeds were collected where the grass had burned to stubble and the cattle pens stood empty. The numbers told their own story. Tepary required 75% less water than pinto beans and still produced a harvest when almost everything else failed. Across the Atlantic, researchers at ICRISAT's Sahel Station logged another breakthrough. In 2023, drought-tolerant cowpea lines outperformed conventional varieties by up to 45% in yield trials, setting pods where maize and soy wilted. The breeding reports read like dispatches from the front lines of climate change. Cowpeas thrived on less than 300 millimeters of rainfall, feeding families through months when the market shelves ran bare. In field diaries, farmers described the relief of seeing green vines after weeks of dust storms. The revival is not confined to research plots. Over the past decade, amaranth sales in North America have surged by 300%, driven by bakers and home cooks searching for protein beyond the feedlot. Lupin flour, once a Mediterranean curiosity, now appears in supermarket aisles from Perth to Portland. These crops are not relics. They are gaining ground, field by field, market by market, as the world rediscovers what resilience looks like in the language of seeds and survival. Right now, over 2 billion people face protein insecurity, while climate extremes threaten conventional agriculture. Yet crops like tepary beans and amaranth, once erased, still thrive where livestock fails, offering protein and resilience without extraction. The future of food isn't hidden in a lab. It is buried beneath our feet, waiting to be remembered. The question is, will we let these seeds grow again? Share your thoughts below.